Have you ever stopped to think about the invisible layers of safety built into your car? I mean, far beyond just the airbags and seatbelts. There's a whole world of engineering, really, dedicated to meticulously planning for, well, every conceivable malfunction.
It's quite something.
Today, we're taking a deep dive into a crucial blueprint for automotive functional safety, the ISO26262 standard. And specifically, our focus is Part 3, which lays out the entire concept phase.
In this phase, it's not just important, it's truly the absolute bedrock, the bedrock of a vehicle's functional safety life cycle.
Like the foundations of a building.
Exactly like that. Imagine building a skyscraper. This is laying those essential foundations. Without this initial really meticulous work, you just can't possibly prevent dangerous malfunctions down the line.
Right.
It fits perfectly with what's known as the V-model development process, that common life cycle where development flows down one side and verification flows up the other. It ensures quality at every step.
Makes sense.
So understanding this concept phase, it really is a shortcut to being, well, properly informed about modern vehicle safety engineering.
Okay, let's unpack this then.
Yeah.
It seems logical that before you can even start making something safe, you absolutely have to know precisely what it is you're dealing with.
Absolutely.
So as we kick off this concept phase, what's that foundational first step? What do you need to do, and why is it so critical?
Right. That absolutely critical first step is called item definition. Clause 5 in the standard, actually.
Item definition, okay.
And its main job, its objective, is to thoroughly explain and describe the item itself, the specific system or component we're focusing on.
Gotcha.
This means detailing its core functionality, how it interacts with the driver, the environment, other parts of the vehicle, all of that. The goal here is really to create such a complete understanding that everyone involved in the later phases can proceed without any ambiguity, no confusion.
So it's definitely not just a quick sketch on a napkin then. What kind of detail are we really talking about in this definition?
Oh, it's incredibly comprehensive. Yeah, definitely not a napkin sketch.
Okay.
The item definition needs to spell out the functional behavior at the vehicle level. That includes all its different operating modes or states.
All of them?
All of them. Plus, it specifies the item's interfaces and boundaries and any assumptions about how it's going to interact with other systems.
Okay.
We're talking environmental conditions it might face, relevant legal requirements, international standards, and even the potential consequences if its behavior falls short. That includes known failure modes and hazards.
Wow, that's thorough.
It has to be. And what's particularly crucial here, something that can sometimes get overlooked, is detailing the capabilities of actuators.
Actuators, like motors and things.
Exactly. Things like a motor's torque output or the speed of an operation. These details might seem small, but they are absolutely vital for the later risk assessments.
Why is that?
Because they directly influence the potential magnitude of a hazard. Think about it. A fuzzy definition early on, that creates immediate blind spots later.
Right. You can't assess risk if you don't know the capabilities.
Precisely. Without that crystal clear definition, you simply can't effectively assess what could go wrong. It's the fundamental who, what, when, where for the system's safety.
That's fascinating. Okay, so with the item now clearly defined, here's where it gets really interesting, I think. Figuring out what dangers it might actually pose.
The next step.
This leads us to hazard analysis and risk assessment, or HARA. Well, what's the overarching goal with HARA?
Right, HARA, Clause 6. The goal here is essentially twofold. First, it's about identifying and classifying every hazardous event that could possibly be caused by the item malfunctioning.
Every single one.
That's the aim. And second, it's about formulating specific safety goals for these events and assigning them an Automotive Safety Integrity Level, or ASIL.
ASIL. Okay, we'll get to that.
Yes, and the purpose of the ASIL is to ensure any unreasonable risk is completely avoided. Now, the real genius of HACAR, I think, and a key principle in the standard, is that it's performed on the item without any internal safety mechanisms assumed to be in place.
Ah, okay, so you look at it raw, basically.
Exactly. You're assessing the raw, inherent potential for harm before you've even thought about designing any specific safety features or mitigations.
That makes so much sense. You want to understand the baseline risk first. So how do they actually go about identifying these hazards? Are there common pitfalls people fall into?
Well, the process starts with a very careful situation analysis and hazard identification. Teams meticulously describe operational situations and modes driving conditions, basically where a malfunction could lead to a hazardous event.
Okay.
And this includes considering both correct use and, importantly, reasonably foreseeable misuse of the vehicle.
Foreseeable misuse.
Interesting.
Yes. And it's crucial that these hazards are defined at the vehicle level, not down in the weeds of component failure modes yet, but the effect on the vehicle and its occupants.
Right, the big picture effect. Exactly. Common missteps often involve not thinking broadly enough about all possible operating scenarios, or maybe not fully considering the human interaction element. To help avoid this, the standard suggests using methods like failure mode and effects analysis, FMEA, or hazard and operability studies, HAZOP. These are excellent systematic tools.
So structured approaches help.
They do. It's all designed to uncover every potential danger in a systematic way.
Okay, so you've identified the potential hazards.
Yeah.
Now, the big question. How do you quantify their risk? This is where severity, exposure, and controllability come in, right?
Yeah.
Leading to the ASI.
That's exactly right. Those three pillars.
Let's break them down. What exactly do each of these factors represent? Maybe start with severity.
Okay, so once hazards are identified, they're classified using these three factors. Let's start with severity, or S. This estimates the potential harm to any person at risk.
Any person. Driver, passenger, someone outside.
Anyone. Driver, passengers, other road users, pedestrians. Anyone potentially affected. The standard gives us 4 classes. S0 is a no injuries, may be just material damage.
Okay.
S1 is light to moderate injuries. S2 covers severe or life-threatening injuries, but where survival is probable. And S3 is the highest. Life-threatening injuries where survival is uncertain, or fatal injuries.
S3 sounds pretty grim.
It represents the worst outcomes, yes. Now, there's a nuance here, too. If an accident isn't directly caused by the item malfunction itself, the severity might be limited to just the difference in harm caused by that malfunction.
Okay. That makes sense.
And importantly, if a hazardous event gets classified as S0, no injuries, then no ASIL assignment is needed. The risk, from a harm perspective, is considered negligible.
Got it. So severity is about the consequence, the how bad is it? What about exposure? That sounds like, how often you might encounter the risky situation itself.
Precisely. Exposure, or E, is an estimation of the likelihood of that hazardous operational situation actually occurring.
Like driving in the rain or on a highway?
Exactly. The standard outlines classes from E0, which means incredible or practically impossible, up to E4, which is high probability, meaning it happens frequently.
Okay.
Now, here's a critical distinction, and one that often surprises people.
Oh.
The number of vehicles equipped with the item is not considered when you estimate exposure.
Really? Why not?
Because you're evaluating the probability of the situation occurring, assuming the item is present in a vehicle. It's about the inherent frequency of the scenario itself.
Okay, I see. So it's not diluted by how many cars have the feature.
Correct. You're looking at things like the likelihood of driving in snow and ice, maybe heavy traffic stop and go, or specific situations like towing a trailer.
Right.
And for those situations deemed incredible, like a true force majeure event, the standard literally gives the example of an airplane landing on a highway.
Chuckles. Okay, that's specific.
It is. Those can be classified as EASER, meaning no ASIL assignment is needed for that specific outlandish scenario. So yes, they really do try to think of everything.
That distinction about the number of vehicles is really important then. It keeps the focus on inherent risk. So, finally, we have controllability. How does that fit into the puzzle?
Right. Controllability, or C. This is estimated as the likelihood that the driver, or perhaps other people involved, can actually avoid the specific harm once a hazardous event starts unfolding. Can they react in time?
The human factor, or system reaction.
Primarily the human factor at this stage, yes. The standard classifies this into C0 for controllable in general, C1 for simply controllable, C2 for normally controllable, and C3 for difficult to control or basically uncontrollable.
Can you give some examples? That seems a bit abstract.
Sure. The standards annexes actually provide good examples. Think about an unexpected loud blast from the radio. Annoying, maybe startling, but generally easy for the driver to handle, turn it down or off. That might be C0.
Okay, easy enough.
Now, consider a failure of the ABS system during an emergency braking situation. The driver can still brake, but it's harder to maintain control. That might be C2, normally controllable, but definitely more challenging.
Right, much harder.
And then something like a faulty airbag deploying unexpectedly at high speed, that's almost certainly C3. Very difficult or impossible for the driver to control the situation safely.
Definitely C3. Okay.
And just like with S-Aero, if a hazardous event is classified as C0 controllable in general, then no ASIL assignment is required for that hazard either.
Okay, so S, E, and C. The ASILs is born from these three factors.
Yeah.
Once you have those ratings, how do you actually combine them to get that final ASIL? And crucially, what does this all mean for the safety goals themselves?
Right. So the ASIL, the Automotive Safety Integrity Level, is determined by literally combining the S, E, and C classifications using a specific table, a matrix that's defined in the standard.
A lookup table, basically.
Pretty much, yes. Table 4 in Part 3. This matrix spits out one of 4 ASILs. ASIL A is the lowest integrity level that still requires functional safety measures.
Okay.
All the way up to ASIL D, which demands the absolute highest integrity and the most rigorous development processes. Maximum scrutiny.
A to D, lowest to highest rigor. What if it doesn't result in A, B, C, or D?
Ah, good question. There's also QM, which stands for quality management. This indicates that for that particular low-risk hazard, general automotive quality management processes are considered sufficient to manage it.
So no specific ISO26262 safety requirements needed.
No rigorous ones tied to SA through D, no. Basic quality practices are deemed enough for QM.
Okay, and these ASILs then, they directly inform the safety goals, which I assume are the ultimate targets you're aiming for.
Absolutely, spot on. A specific safety goal is determined for each hazardous event that ends up with an assigned ASIL, so anything from A to D.
Right.
These safety goals are essentially the top-level safety requirements for the item, the big objectives. And it's really crucial that they're stated in terms of functional objectives, not specific technologies or solutions.
Can you give an example of that?
Sure. A safety goal might be something like prevent unintended acceleration above 5-mile-per-hour when the brake pedal is pressed. It says what needs to be achieved safely. Exactly. It doesn't say use this specific sensor or implement this algorithm. That keeps the design options open for later stages.
Alert.
And one more point. If you have several similar hazardous events that lead to similar safety goals, you can sometimes combine them. But if you do...
Let me guess. You take the highest ASIL.
You got it. The highest ASIL among the combined hazards gets assigned to the overarching safety goal. Yeah. You always default to the more stringent requirement.
Ensures the highest level of safety is targeted. Okay, so we have identified the item, assessed the risks via HERA, set our safety goals with ASILs. Now comes the conceptual solution part, right? The functional safety concept, or FSC.
Precisely. Clause 7.
What's its main purpose? Is this where we finally start outlining the actual safety solutions?
Exactly. The functional safety concept, the FSC, is where we begin to sketch out those high-level solutions. Its core purpose, its objective, is to specify the required functional behavior of the item, or even how it should behave in a degraded but safe way if something goes wrong. And all of this has to be in accordance with those safety goals we just defined.
Okay.
It also sets the necessary constraints for things like how quickly faults need to be detected and controlled. And it starts outlining the strategies or measures needed to achieve fault tolerance or mitigate the effects of faults.
So it's translating goals into requirements.
Yes. Essentially, the FSC translates those sometimes abstract safety goals into more concrete, actionable, high-level functional safety requirements, FSRs.
FSRs, got it.
This is really where safety moves from the what if of FSR to the how do we prevent or mitigate its state.
Right, making those safety goals truly actionable.
Yeah.
What kind of strategies do these FSRs actually specify? What do they cover?
Well, the FSC, through the FSRs, gets quite specific about how safety will be achieved conceptually.
Right.
It outlines strategies for fault avoidance in the first place, designing things robustly.
Yeah.
How faults or malfunctioning behavior will be detected and controlled once they occur. And critically, how the system will transition to and maybe back from a defined safe state.
A safe state, like shutting down.
It could be. A safe state might mean the system simply switches off. Or maybe it operates with reduced functionality like limp home mode, but only for a defined period, the fault-tolerant time interval.
Right.
The FSC also covers strategies for fault tolerance, how the system might continue to operate safely even if a fault is present, or how it degrades functionality gracefully, not abruptly.
Okay.
It specifies how driver warnings will be used. Think of your engine malfunction light or ABS warning lamp to alert the driver and reduce risk. It nails down timing requirements, like how quickly a fault must be detected and reacted to.
Lots of detail there.
Absolutely. It even addresses complex things like avoiding hazards that could arise from improper arbitration, basically. Exactly. Conflicts when multiple systems try to control the same thing simultaneously.
Like steering assist and lane keeping fighting each other.
Potentially, yes. The FSC needs to define how those conflicts are safely managed. And then these comprehensive requirements, these FSRs, they get carefully allocated, either to elements within the preliminary system architecture or sometimes even to external measures, like telling the driver to perform a specific check. It ensures every piece of the conceptual solution contributes to meeting those safety goals.
Okay, if we try to connect all this to the bigger picture then, these three core activities we've discussed, item definition, HARA, and the functional safety concept, they clearly aren't isolated tasks.
Not all.
How do they really fit together? How do they lay the groundwork for everything that follows in the actual vehicle development?
Yeah, they are deeply interconnected. They form this coherent, traceable flow of logic and requirements. Think of it as a step-by-step progression, where each step provides the absolutely essential input for the next one.
So item def feeds HAR.
Exactly. The item definition is the non-negotiable starting point for hazard analysis and risk assessment. You just can't identify hazards if you don't clearly know what it is.
Right.
Then the ARA directly generates the safety goals along with their assigned ASILs. That quantifies the risk level precisely. And finally, those safety goals, driven by the HARA results, are the direct input for creating the functional safety concept. The FSC specifies how those goals will be met through those high-level FSRs.
It really sounds like a chain reaction, but a very deliberate, documented one.
That's a great way to put it. Deliberate and documented. This sequential, yet often iterative process, because you might loop back based on findings.
Oh, okay.
It provides this robust and traceable foundation for all the subsequent, more detailed development phases. System design, hardware design, software development, all of it builds on this concept phase.
Ensures safety isn't just bolted on at the end.
Precisely. It ensures safety is ingrained from the very first thought, aiming to avoid any unreasonable residual risks remaining in the final product. And crucially, throughout this entire concept phase, there are built-in verification activities specified.
Checks and balances.
Exactly. For instance, after HRA, you verify, did we identify all relevant hazards? Are the SEC classifications appropriate? After crafting the FSC, you confirm. Do the FSRs logically follow from the safety goals? Do they actually address the identified hazards? It's all about building safety in layer by layer with rigorous checks at every turn before you move on.
Wow. What a deep dive.
Yeah.
We've really covered how the ISO26262 concept phase meticulously defines a vehicle component or system, identifies seemingly every possible hazard, quantifies the risk using severity, exposure, and controllability to assign that critical ASIL, and then crafts that high-level safety strategy, the FSC, to meet those demanding safety goals. It's truly remarkable how much upfront thinking and planning goes into ensuring our safety on the road.
It really is. And this foundational work, it's literally saving lives by integrating safety thinking right from the very beginning of a vehicle's design. You know, this raises an interesting question thinking ahead. Given the increasing complexity of vehicles today, especially with the rise of more autonomous functions, how might future automotive safety standards like ISO26262 need to evolve? Particularly when you consider that controllability factor.
Oh, right, because the driver might not always be human.
Exactly. How do you assess controllability when the driver making the split-second decision might be an AI? That whole paradigm is shifting. It's definitely something to mull over until our next deep dive.
Absolutely fascinating point. Well, thank you for joining us on this deep dive into the core of automotive functional safety, specifically ISO26262-Part 3. We really hope you, listening in, feel better informed and maybe more curious than ever about what goes into making our vehicles safe.